Oof, the sun. All right, we are in chapter 1, lesson 2. The title of this lesson is, so we're doing a whole bunch of quadratics in the whole chapter. And here we're going to do graphing quadratics in vertex or intercept form. Let's see if I can fix that. Vertex or intercept form. I'm just going to have a stripe down the middle of my face. It's going to be fantastic. So what is vertex form? What is intercept form? So we're going to start out with vertex form, which you see right here. These are the key concepts. So vertex form is the form y equals a times the quantity x minus h. Oh, I need to move this guy. Should have done that before I started. Here we are. So a times the quantity x minus h squared plus k. That's called vertex form because our vertex is actually an ordered pair in here. All right, so let's just read this. The graph of y equals a times x minus h quantity squared plus k is the parabola y equals ax squared. Let's remember the parent function, parabola, but we're going to translate that horizontally h units and vertically k units. So if our parent function is y equals x squared, or y equals ax squared, I'm going to move it h left and right and k up and down. So here, x minus h means I move to the right h and up k. Now that's x minus h. If we had x plus h, quantity squared plus k, that means I'd be moving it to the left and up because it's plus h, which is the same as minus a negative h, which is why I move it to the left. Okay, because my format says x minus h. That's what my format says. So if I have an x plus h, that should be plus. That really means I have a minus a negative, and I'm moving it to the left. Now, what if I make it minus k? Minus k. That means I move it down. Okay, h is horizontal, left and right. K is vertical, up and down. Now, the axis of symmetry is just x equals h. You just have to read it from the equation. And then the graph opens up when a is positive and opens down if a is negative. That has not changed. Okay, all right. My pen back to black and move on. So let's try one. Graph a quadratic function in vertex form. So here we have h is negative 2, k is 5. So my vertex is actually negative 2, 5. And my axis of symmetry is the line x equals negative 2, which you see both of those things right here. Vertex is negative 2, 5, and the axis of symmetry is x equals negative 2. Okay, so we're getting towards graphing it. We also want to identify that a is the value negative 1/4. That means that we are going to open it down, unhappy parabola. H is negative 2, k is 5. Yep. We plot the vertex, draw the axis of symmetry. All of that is a check. Now, let's evaluate the function at 2 more values. I think I can. Yep. So we're going to evaluate that function. Let me write it down again. X equals negative 1/4 x minus h plus k. So let's just evaluate it at 2 values of x. We have not used x equals 0 yet, and we really like x equals 0 because it's easy to compute. So negative 1/4, 0 plus 2 squared plus 5 equals negative 1/4. 2 squared is 4 plus 5. These cancel out. I'm left with a negative 1. Negative 1 plus 5 is 4. So that's going to be the value 0, 4. So we're at 0, 1, 2, 3, 4, right there. Then I'm going to flip that over the axis of symmetry and put one right there. Now let's do another one. Let's try x equals 2. We've got a 1/4 out in front, so I'd like to keep everything and stuff I can do easy math with. So now we have 2 plus 2 squared plus 5. Negative 1/4, 4 squared. 4 squared is 16. So negative 1/4 times 16 plus 5. That would be negative 1/4 times 16 is negative 4 plus 5 is 1. So my ordered pair is 2, 1. So let's go over 2 up 1 and then reflect it over the axis of symmetry. 4 away, 4 away. There we go. And now we can draw a smooth curve through all of those points. I like the vertex form. The vertex form is very useful. In fact, as your algebra 2 gets harder, it's useful, and it's also very useful in calculus. Okay, so using a quadratic model in vertex form. Civil engineering. The Tacoma Narrows Bridge in Washington has 2 towers that each rise 307 feet above the roadway and are connected by suspension cables as shown. Each cable can be modeled by the function given, where x and y are measured in feet. What is the distance d between the 2 towers? So we want to find what this distance is, right? So what we're going to do is, well, let's figure it out. We are in vertex form. I'm going to actually move this up and rewrite that equation. I need space to work, right? So the equation is y equals 1 over 7,000 times x minus 1,400 squared plus 27, right? So our vertex is actually, h is going to be 1,400, k is going to be 27. So that's our vertex. If we looked at that bridge, we are over and up 27. Now we were trying to find the distance from here to here. We also know that the axis of symmetry is right there. So this distance and this distance are going to be equal. I just used a little congruent mark. So from 0 to 1,400 is great. Then we're going to go from 1,400 to the end, which is 2,800. So that total distance is going to be 2,800 feet. So a problem that looked kind of daunting actually wasn't once you dissected all the stuff. All right? All right, we have a few guided practice. Graph the function, label the vertex and axis of symmetry. So here I have a equals 1, h equals negative 2, because remember it has to be x minus h. And then k is, it's not a good k. I thought I found the undo. I didn't. K is negative 3. So my vertex is negative 2 comma negative 3. My axis of symmetry is x equals negative 2. And then we have to find a few more points. So let's go ahead and calculate it at x equals 0. 0 plus 2 squared minus 3. So 2 squared is 4, minus 3 is 1. That's a 1. So that point's going to be 0, 1. Now let's go ahead and try another point. Let's see, we plot the vertex, we plot the x-axis. We have x equals 0, 1. Let's go ahead and reflect it over. And then let's just do x equals 1. 1 plus 2 squared minus 3. 3 squared is 9 minus 3, so 6. That means my ordered pair is 1, 6. And that's not right. What did I do? 1 plus 2 is 3 squared is 9 minus 3 is 6. So if I go over 1, it should be -2. 1 plus 2 is 3 squared. Huh. Oh, because I'm not at the x-axis. That's hilarious. So if I went over here to 1, I'd be 1, 2, 3, 4, 5, 6. Up there. So sorry. Which means I reflect it over here and it'd be up here. Golly, that was hard. I like using different colors. Like this right here is the axis of symmetry, not the y-axis. Whew, we almost had Miss Carly in a big old conundrum. All right, let's try another one. So here I have a equals -1, open and down. H equals 1 and k equals 5. My vertex is 1, 5. My axis of symmetry is x equals 1, which we see right here, axis of symmetry and vertex, and definitely open and down. So let's go ahead and try a few more points. If we do x equals 0, I'm going to have negative. That gives me -1 plus 5 is 4. So 0, 4. 0, 1, 2, 3, 4, and then reflect that guy over. Now let's go ahead and do x equals 1. 1 minus 1 is 0. So I have -0 plus 5. So my ordered pair would be 1, oops, that's funny. Over 1 up 5. Oh, for goodness sakes, it's my vertex. You really don't want to do the vertex. You guys are catching all my mistakes. Let's try x equals 2. 2 minus 1 squared plus 5. I already did x equals 2 because it reflects over x equals 0. X equals 3. 3 minus 1 squared plus 5. 2 squared is 4. So 3, 1. 1, 2, 3, 1. Woo! Reflected over. 1, 2, 1, 2. And then we can draw our unhappy parabola. You really should take your time when picking your extra x values, or you'll be doing math over and over again for no reason. All right, guided practice. I'm not going to spend too much time on this. A is 1/2, H is 3, K is -4. So my vertex, 3, -4, axis of symmetry. Okay, we just did this. Now you pick some more points and graph. And you see the graph there. Another guided practice. So here, suppose an architect designs a bridge with those cables. Look how we have a different a value, where x and y are measured in feet. Compare this function's graph to the graph of the function example 2. Is this a happy parabola or an unhappy parabola? It's happy. Our vertex is still going to be at 1,427. Oops, 27. So it still looks like this. That means that our total distance is still going to be 2,800. Is there a funny ending to this that I'm unaware of? Oh, we're just talking about this would be slightly steeper because this number is different. If you look at the other one, it was 1/7,000. So the fraction has gotten slightly smaller. And that just means that we are going to be same vertex, same axis of symmetry. They both open up, but slightly steeper with a different a value. All right, new key concept. This is in your notes. Graph of intercept form, y equals a times x minus p, x minus q. So this right here is called the intercept form. It's the intercept form because p and q are your x-intercepts. It's where it crosses the x-axis. So x-intercepts are P and Q. Notice they're minus and minus. The axis of symmetry is halfway between P and Q. So really, the axis of symmetry, you're going to add P and Q together and divide by 2. We still are happy and sad. Yeah, let's practice some of these. All right, so here we have A equals 2. I don't know why I'm still in green. P equals -3, and Q equals 1. So my axis of symmetry is going to be halfway between. -3 plus 1 over 2 is -2 over 2, which is -1. So my axis of symmetry here is the value x equals -1. So if I were to draw this, -1 is my axis of symmetry. And P is -3. 1, 2, 3. Q is 1. What is the y value of my vertex, though? I'm going to go ahead and take that -1 and plug it in. -1 plus 3, -1 minus 1, 2, -2, -8, -1, comma, -8. I could pick some more points, but really, this does a great job. That's a beautiful parabola. So draw your parabola through the vertex and the x-intercepts, and you're golden. Oh, and there we go. The picture from the book. All right, so let's try another one. Use quadratic function in intercept form. So the path of a place-kicked football can be modeled by the function y equals, is there a mistake there? Nope. -0.026x, there's the x, and then times x minus 46, where x is the horizontal distance in yards. How far is the football kicked? So I'll write down here. We have y equals -0.026x. I'm just going to do this. Actually, I'm going to do this. I'll show you something. Because we have x plus p, or, being a little pokey here. Oh, there we go. Remember our vertex form was minus p and minus q. That's really what we have there. So where x is the horizontal distance and y, so how far is the football kicked? Here, right there is 0 from this one right there. And then this one is going to be 46 from that one right there. So the football was kicked 46 yards. Beautiful handwriting. And then the maximum height is going to be, I need to go halfway between there and find what the height is. So really I'm going to take 0 plus 46 and divide it by 2. So I'm going to have 23 comma something. But I need to go back into the equation and find the y value that matches with 23. So the axis of symmetry is x equals 23. Okay, need more paper. So what's my equation again? Let's get it. Y equals -0.026x times x minus 46. So we found the axis of symmetry is 23. Let's plug that back in. -23 minus 46. So we plug that back in and do a little handy-dandy calculating. I got 13.8. So if we, oh gosh, that's terrible. I'm so sorry. From 0 to 46, axis of symmetry was x equals 23. That means my maximum point is at 23, 13.8. I know it's unhappy. I forgot that right there because I have a negative out in front of my a term. Okay, the maximum height is the y coordinate, which is 13.8 yards. Say max is 13.8 yards. Right, and then we're going to practice a few. So graph the function labeled its vertex, axis of symmetry, and the x-intercepts. Here I have p equals 3, q equals 7. My axis of symmetry is the line x equals 3 plus 7 over 2, or 5. So that's what I've drawn right there. I don't know what the y value is of my vertex, so let's go ahead and figure it out. Plug in 5. Oops. X minus 3, so 5 minus 3, 5 minus 7. 5 minus 3 is negative 2. Nope, 5 minus 3 is 2. 5 minus 7 is negative 2. So that gives me a negative 4. So my vertex is 5, negative 4. So I plot my vertex. I know that I'm crossing the x-axis at 3 and 7. So 3 and 7, and I have enough to make a happy parabola. Happy. P equals 4, Q equals negative 1. So x equals negative 1 plus 4 over 2, blasted, 3 halves. That means my y value is going to be 2, 3 halves minus 4, 3 halves plus 1. I think I can go ahead. Yep, I'm going to go ahead and, no, I can't. I'm going to have to do the icky math. We all love fractions, we really do. So 3 halves minus 4, 1.5 is 2.5, 3, 4, yep. Times 3 halves plus 1 is 2.5 times 2. Let's see, number 6. Yep, that's the one I'm on. Yeah, so that gives me negative 12.5. So my vertex is 3 halves, negative 12.5, 6 halves. Yeah. 2, 3, 4, 5, 6 and a little bit. Oh, 12 and a little bit. Awesome. All right, so I plot my axis of symmetry. I plot my vertex. Then I plot these 2 points at 4 and negative 1, and I have enough to draw through. Nope. P. Aw. So halfway between that, x equals 5 plus negative 1 over 2 is 2. Y, I'm going to plug that in. 2 plus 1, 2 minus 5. 3 times negative 3 times negative 1. So my vertex is 2, 9. Right there. Axis of symmetry is 2. Right there. I plot negative 1 and positive 5 and draw my parabola. All right, so what if in example 4, what's the maximum height of the football if the football's path be modeled by this function? So this is a very similar function. My axis of symmetry is going to be 25 this time because it's halfway between 0 and 50. I would have to plug that in. to find the maximum. Negative 0.025 times 25. So this would be negative 25 times 25 times negative. I actually did not bring my calculator into my room to do this. I'm going to look it up. Yep. I got 15.625 yards because that's the y value of the vertex. All right, last but not least, FOIL. Okay, this is where multiplying two expressions, two binomials. Okay, we say two expressions that each contain two terms, that is binomials. Add the products of the first, the outer, the inner, and the last. We also learned it like this. That should be a square. We learned it sort of by calculating area of things. X plus 4, x plus 7, where we multiply x times x and get x squared, x times 4, x times 7, and then 4 times 7. And then we add up everything in here. X squared, 4 plus 7, and then 28. Okay, so here I call this the box method, very technical term. And this we call foiling. F-O-I-L. First, outer, inner, and last. That should be a bit of a review. So when we want to change things from intercept form to standard form, we take this and we FOIL it. I will generally FOIL with my more advanced students because it's just something we need to learn to do in our head. With our emerging students, we will definitely do the box. We always do this last, okay? So collect like terms, x squared, I have a negative 8 and a positive 5, gives me a negative 3. And then I'm going to distribute that negative 2 through. Negative 2x squared plus 6x plus 80 would be my answer. Let's go ahead and check that. Make sure I didn't mess anything up because it happens. We got it. Okay, with this one really quick, I'm going to do the box method, but we still have to make that negative 2 wait until the end. X plus 5, x minus 8, x squared, negative 8x, positive 5x. I'm just multiplying the row and the column, Okay, so it's all nice and neat in the box, and then I collect like terms, and I usually cross them off when I collect them. And then I'm going to go and grab that negative 2 and distribute. And we get the same answer, okay? I think foiling's fun. I really do. All right, now we're going to change from vertex form to standard form. This right here is actually x minus 1 twice, right? The worst mistake students can make, but it's so common, is to say x minus 1 quantity squared is x squared plus 1. Okay, common mistake, not true. X minus 1 quantity squared is x minus 1, x minus 1. Let's go ahead and FOIL it. X squared minus 1x minus 1x plus 1. Now we have a 4 on the outside. My handwriting got a little bad there, I'm sorry. First I'll collect like terms. X squared, I have minus 2x plus 1. Then I'll distribute the 4. PEMDAS says distribute this first, then add the 9. 9 plus 4 is 13. Let's check our work. Got it. Okay, good job. We have a few guided practices and then we'll be done. All right, I'm not going to go through each one of these. I will give you the answer. There's like 8 of them. Okay, if you would like to double check before you start your homework. Go ahead and use the box method. That should be 14. Should not be lazy. And it should actually erase. Wait, so go ahead and use the box method. 9, 10. Or first, outer, inner, last. You will get the same results as long as you know how to use them. Now, why am I writing f of x for some and y equals x, y equals the equation for the others? Some of these are just written in function notation, and some of them are written as y equals. It doesn't matter. It really doesn't matter until we start using the function notation or until we start graphing. So 12, y equals negative 7x squared, 35x, 42. Ooh, here's one where we would write x plus 5 twice. And after we're done foiling it, we would distribute the negative 3, and then we would subtract the 1. 13. Negative 3x squared minus 30x minus 76. 14. G of x. Why g of x? Well, it's just a different way to name. F of x is like calling something Fred, and g of x is like calling something Gary. It doesn't matter. It's just a different name for an equation. Now you can push pause on these videos at any point. Again, here I'm going to write x plus 2 twice, and then distribute the negative, and then add 4. There we go. And then the last one, y equals 2x squared minus 12x plus 27. That's all I got. Okay, that was a long first day of Algebra 2, but I hope you're getting the material and we will set up some time to talk. Nice job today.